Next up, valid palindrome, leak code number 125. I'm gonna be honest, this question is pretty annoying, and you'll find out why soon. But we still have to do it because it's just so common. Also, one of our approaches is going to introduce another new pattern that we will use for the entire course, and that pattern is the pointer method or pointer traversal. So this video is a must-watch for those two reasons. And now for a quick definition. Given a string, determine whether it is a palindrome. And in case you didn't know, a palindrome is a word spelled the same backwards as it is forwards. Here's a few examples: race car, level, rotator. Input and output for this one are pretty simple. A string will go in, and we will return a true or a false Boolean value. This time, our string might have special characters such as spaces, punctuation, and similar. So we're going to have to be very careful and use a special technique to deal with that. Given this edge case, we will assume that we want to remove these special characters, as well as treat upper and lowercase letters as the same character. This is the first problem we're going to discuss naive solutions for. Naive solutions are problems with a solution that is very obvious, but not necessarily the best solution. For problems with naive solutions, your interviewer will either expect you to solve quickly for the naive solution first, or at least acknowledge it exists. Interviewers like these questions because a big part of solving algorithms is comparing different solutions. And in most of these cases, one solution is more optimal than the other. Can you come up with the naive solution for this one? If it's not obvious, consider this. There are two versions of the string we pass in, the forwards version and the backwards version. If we compare these, we can determine whether the string is a palindrome. JavaScript and Python both have built-in methods to reverse strings, and after we reverse, we just have to do a simple equality check. This is pretty straightforward, so let's jump directly over to our code. We'll code this out by creating a reversed version of this string and comparing it to the original string. And the way we do that is again by first converting the string to an array, then calling the reverse method on that array, and then finally joining it back together. So in code, this looks like this. We call the split method on our string with the empty string delimiter. Then we have a built-in reverse method for arrays, and finally we join it back up into the original form. So if we had a string like ABA, split would take us to an array with the characters ABA, and then join would take us back to a reversed version, in this case, which is the same, ABA. So now all we do is compare that to S with a triple equal that evaluates to a true or false that we can return. Now that we've coded that up, let's look quickly at the time and space complexity. We've got split, reverse, and join, three methods chained together in sequence. Under the hood, these methods are moving these characters around to transform them one by one, so we have n time for each. So we're looking at three n's in sequence, n plus n, or 3n. We drop the constant, that leaves us with O of n linear time. Now in terms of space complexity, even if we don't explicitly put the reverse string in a variable, it must be stored in a temporary location by the programming language to do this comparison. Therefore, we're using an implicit O of n space. If you tried to run this in LeetCode, you might have noticed it doesn't work. And that's because we have special characters in our test inputs. This might be part of the reason why there's so many downvotes on this question in LeetCode, but in the real world of programming, you don't always have a clean input. So it's a good thing to practice. And it is totally fair game in an interview. To be clear, let's define unclean as having spaces or special characters. So we're going to want to remove these characters that we've determined as noise. And in the programming world, you'll hear this referred to as cleaning the data or sanitization. So how do we sanitize a string with spaces and special characters? Well, it actually depends on what language we're using. So let's jump back over to our code editor. There's a few different ways to remove special characters and spaces, but I'm just going to go with the simplest way, which is with a regular expression. If you haven't encountered these yet, they are actually pretty useful. They help us search and manipulate strings, and in this case will allow us to sanitize our input. So I'm going to paste one in here from Google, and I want to stress that you shouldn't try to memorize this syntax. Just know what this is doing is replacing everything that is not an alphanumeric character with an empty string or nothing. There's actually so many things you can do with regular expressions. No one is going to expect you to memorize the syntax, which is frankly a bit arcane. And in real life, you can always Google it. So in an interview, if you get asked a question where you can use regex, either ask your interviewer if you can Google it or if they can look up some syntax for you. So I'll just save the result of this regex into a variable called san, standing for sanitized, and then I'll replace the s down here with san, just to make sure we're working with that sanitized input. Lastly, there's one more thing we want to do. Let's say our string is a man, period, and we run it through the regex. Well, that'll convert it to a man, but recall that we also want to convert uppercase to lowercase. JavaScript does not see an uppercase a and a lowercase a as the same. We actually mentioned this all the way back when we stated our assumptions, and all we have to do to further process this is to add a to lowercase method call at the end, which is a string method that works on any string. It's at this point your interviewer might say, is there a better way we can do this in terms of time or space? The short answer is yes, we can do slightly better on both frontiers. Hopefully the first place your mind jumped was to the hash table. And that's great because that's a reflex we want to create with the first two questions. But the hash table does still have the shortcomings of using extra space, and it also wouldn't test the order of the characters because it doesn't guarantee any ordering, as we already know. So let me introduce another pattern that's going to come in handy not only for string algorithms, but other data structures as well. And that is the pointer method. If you've written a for loop, you already know how pointers work. When we increment the I, it is pointed to one additional index on every iteration or step. Armed with this pointer method and some creative thinking, we can see that palindromes are actually kind of like reflections from left to right. So what if we started with a left pointer and a right pointer and then move them towards the center? If at any point they don't match, then we know we don't have a true palindrome. On the other hand, if they reach the middle, we know we've checked every character. If you're thinking right now, how the heck can you come up with this on your own? Well, the answer is, it's hard to do that. But once you know about the pointer method, it's not as hard. And now you do know about it. So let's go ahead and implement this in code. Here's some pseudocode for the pointer method. A little hint, you're going to use a while loop and manually advance the pointers towards the center. Give it a shot if you want, then let's code it up. So there are two main ways you can do this dual pointer method, and both are equally effective, but I think one is a little bit more clear. So first I'll mention the one we're not going to do. That'd be if you just create a standard for loop and essentially you do math on each iteration. So on one side you have your left pointer and then you do math to calculate how far the right pointer is from the end, because you're moving one space towards the center each time. Now what I think is it's a bit clearer to do a while loop, setting two explicit pointers that you manually move towards the center, just because it's easier to read, easier to understand, and closer to the problems we're going to do in the future. So let's start with the left pointer and set it to 0. That is the first index in our string. And we'll create our right pointer by setting it to the length of our string minus 1, which is our furthest right index in our string. Then we'll do a while loop while left is less than right. So this is probably the most critical part to understand. Once the pointers cross each other, we know we do have a valid palindrome because it implies we have checked everything and then reached the middle. And if we have an even number of characters, then they've completely passed each other, in which case we also have a valid palindrome. Inside of the loop, we're going to want to check to see if the characters are the same, or more accurately, if they're not the same, we want to return false, because at that point we know it's not a palindrome. So if s left does not equal s right, then we will return false. And this will break our loop early. And I already noticed a mistake. Let's do san here and san down here. So got to use the sanitized string. But anyway, now we move our pointers, and there's two places we can do that. We can either do that up here in the while condition, or you can do it inside of your while loop. And make sure you're incrementing left and you are decrementing right. So I think this makes it pretty clear what we're trying to do here. And then of course we have to write our fall through of returning true when everything passes. Moving on to time complexity. We should always be looking for loops So our eyes should jump to that while loop, which is one of the main sources of complexity in any algorithm. Inside the loop, we can see that we're actually doing a bit better than end time because we're only going up to the center before breaking our loop. Remember, the middle is where our pointers will cross and the loop will break. So we get n over 2 time, but unfortunately it still reduces to O of n linear time. So space is where we're hoping to get our main optimization. To be fully optimized though, let's just make one more change, and that is instead of creating a new san variable to store our sanitized string, let's replace our input argument s. That way we're recycling that space instead of taking extra space just to store a string when we're not using the original one. When we recycle this space, we're only using extra space for these extra pointers left and right. That means we're using O of 2 space, which reduces to O of 1, constant space. The main takeaway here should be the pointer method. We're going to be using some variation of moving pointers, whether towards each other, away from each other, or through data structures for most of this course. Is Palindrome is a great question because of this, and because of its multiple solutions. If only it wasn't for that annoying sanitized part. Alright, I'll see you in the next video with another very common question.